Welcome to my talk. This is where we find out if those fries that you say are missing are really missing. Yes, as they said, my name is Felipe, and I'm a data scientist, and I work for Glovo. And my first question is, have you ever had an issue with one of your orders? And I'm sure, all of us in all of these different companies, all these different countries, we've all had issues with orders. It's just, in the nature of the business, is very fast. There's issues with couriers, issues with partners, etc. So refunds are very important to us because, of course, it's the best way to give a customer back for any issue they could have had in their order. And we basically, this talk is about the machine learning model that we created to determine which customers are more likely to commit refund abuse. And basically, we do this because we realize that if you can block the worst abusers directly from the back end, then you can increase the number of refunds you grant automatically to the non-abusers. And that reduces the number of requests that we do to customer service, reducing costs, and also making the experience better for customers. So first, I'm going to explain to you what a refund process looks like. So you basically have these three different options. So self-service or the automatic refund is just basically a series of screens that the app takes you through, all automatic without having to talk to anyone. And at the end, it'll let you pick if you want the refund as credit or if you want it directly to your bank. Customer support, or we call it live ops, is basically the normal customer support that you know and maybe love, which is just a chat window where you can talk to an actual human being and they can, discuss the issues that you may have had. And then you can just get straight up blocked, in which you get this cute little messages that tells you that, yeah, we're sorry, but you're not going to get your refund. Here, the most important thing is that the automatic refunds aren't just better because they help us cut cost, which they do, but they are also good in that they are very frictionless. Like they are very easy for the customer. It's very easy for them to just go through the process. It's super fast. So then, of course, some people take advantage of it. These that we consider refund abusers are customers that are taking advantage of how little friction there is in this process to get basically free things. So we have, they're characterized by like having a high number of refunds compared to the orders that they have. They're usually newer customers or what we call circumstantial abusers, which are customers that have ordered for a long time, but they didn't realize how easy it was to get a refund. And as soon as they get the first one, they're like, oh, I can just do this every time. And they do it constantly. They often have multiple accounts per device, per phone number, credit card, etc. And this is because once they get blocked, they try to maybe do it again with a new account. And they also tend to buy items that can be resold. So, for example, you can find alcohol, like expensive bottles of alcohol, electronics, SIM cards, video games, etc. Basically, things that they can then get their money back for as a refund and then sell them to make like a double profit. So we created the risk score to assess these types of customers. And it is just a score that represents how likely a customer is to commit refund-related abusive behavior. You can see here on the right how we calculate it. Basically, once you place the order in the app, we immediately calculate a risk score for you, just in case that you have some complaint with the order. So by the time you maybe have an issue or not, and you request a refund, the score is already in our backend or in the risk engine. So it can make a decision whether basically to which of the refund options to send you. And think about it kind of like a stoplight. So you have like customers with low risk, they get a green light, they immediately go to an automatic refund. Customers with like a medium risk will get sent to customer support. So like an actual human being can look at your case. And customers that have a really risky score will get a red light, which is basically they'll just get blocked. Now, the biggest problem we've had in this whole thing is that it is very hard to find the ground truth. It is really difficult to know if a customer is lying or they're not. The live ops agents have different ways, so they can ask you for pictures, they can ask the courier, etc. But in general, you can't really know when a customer is lying to you or not. And also, like, even with pictures and stuff, like how you're going to ask someone to take a picture of a missing item. So basically, yeah, as it goes back to the title of this presentation, are those fries really missing? Well, we really don't know. That's why we have this machine learning model, an anomaly detection unsupervised machine learning model. It's unsupervised because, yeah, as I said, we have no target. This is called the isolation forest, the algorithm that we chose. I don't know if you're familiar with it, but it's similar to like a random forest, except the trees are made in a way where the smallest branches give indication of which data points are more anomalous. In our case, we're taking these more anomalous data points as more risky. So we're using a combination of features from the order itself. So if it's the customer's first order, was it paid with promo codes? Then we look at the historical features. So the rate of refunds that this customer has had on his history, how number of contacts or like number of complaints that he had done in the past, number of cancellations, etc. And we also look at the customer's network. We call the network feature. So like how many other customers are in your direct network, which I'm going to explain how the networks work. So the networks are a different model that we use in a lot of things that we do in the fintech data risk team, which is basically just they are basically a graph that connect customers to each other based on either shared devices, shared credit cards, phone numbers, etc. They are, in this model, they are good for identifying, as I said before, abusive customers that are creating new accounts after they've been blocked, because usually they'll have a device, the same phone number, etc. And we can identify, oh, this is actually not a new customer. This is an abuser coming back. And we don't just use them for refunds. We also use the networks for promo abuse, courier fraud, cash abuse, prime abuse, etc. Basically, almost all the models that we have in the team. So this is an example of how it looks like when a refund abuser has a large network. So you can look at this guy. This is in October 2021. And he, just made his account, first time, first order. He only has one phone, one email, one device, and one credit card. And he just got his first refund and totally fine, raised no alert. Now you look a year later, and this person has made 16 different accounts, all of them with a few orders and most of them refunded. And they are sharing, most of them are sharing the same phone number or the same couple of credit cards, the same couple of devices. So now we can identify very easily that this is actually probably just one person, and they are trying to make new accounts, get refunds, and then when they get blocked, move on to the next one. Even once we have these features, it was not enough to capture new customers, identify risky new customers, basically because the most important features of the model were all the historical ones. So we decided to do the split when, if it's your first order, you go to a model that's only been trained with the features that you would have in your first order. So the size of your network, the time since you created your account, whether it's promo codes, etc. And yeah, this like mini model only has these features, so it'll only compare you to other new customers to see if you're anomalous or not. And of course, if you already have a history, then we can use those historical features to compare you to all the other existing customers. And yeah, basically the score is scaled in the same way. So when it arrives to the fraud team, which are the ones in charge of the risk engine, they can just assess them normally. Now, how does the model work when we put it in production? Well, it's very simple. We train it once a week with the data going back 90 days. It's applied in batches because it saves cost instead of applying it live. And it runs every 20 minutes. And this 20 minutes, we decided basically by looking at what was the average time between order and refund time. And basically we realized that you would cover about like more than 99% if you schedule it every 20 minutes. And it's also implemented in our machine learning platform, which uses like Argo and Kubernetes and stuff like that. Is actually very fast. The isolation forest is a fairly fast model. So we've had no issues with that. Most of our speed issues are with like sending messages and queries, you know, the things that people normally have issue with. Now, you might think, you know, because the model is unsupervised, how do you analyze these results? So we're looking at three major things here. So which are the customers that are identified as outliers? Are we identifying the worst ones? And how many non-abusers are being penalized and unjustly, basically false positives? So we have three different ways that we go about this. So the first one is that we do a sampling, weekly sampling of refunds of cases that we send to be manually reviewed by fraud experts, which is another team that we have in the company. And they go one by one, checking like these customers' histories and everything. And they can identify when the model has made a mistake or not. We also have a weekly meeting with them and with other people from the fraud team, basically where we discuss like weird cases, mistakes that the model have made. And this is actually one of, I would say, the best things, the best ideas we've had in this project is that, yeah, if we really involve the stakeholders, and we have through this found so many, like, not just new ideas for features, but also like mistakes and things that the model was doing. Now, another thing we can do automatically is we can check the refund rate a month after we grant you a refund. So if, yeah, let's say we grant you one because we think you're not risky, then let's go back 30 days. Let's see how many you've gotten. Let's see how many times you've ordered, etc., to see if it was the right decision or not. And we also, of course, we have like libraries like SHAP and stuff to check feature importance, to see what is driving the model, what is driving the decisions that it's making. So what has been the most successful and the not so successful about the model since it's been implemented? So it is pretty good at identifying the riskiest customers. And with all these separate model and network features and everything, it is also good at finding abusive customers that are creating duplicated accounts. Now, our biggest issue so far has been with false positives, is that the score can be very punishing if you, like, let's say you have a really bad week, you had 3 refunds, I don't know, something went wrong, and then you might not be granted an automatic refund for a while because the model still considers those 3 refunds against you. We're currently working on ways to make the score less punishing, especially for existing customers, because they are, you know, of course, the ones we want to keep the happiest. So the model has been in production since Q2 of this year in every country. I mean, every of our countries. And we have achieved significant savings, not just by blocking the most malicious customers, but also by reducing the cost of all these refund requests that would have gone to customer service that now we can do automatically. It's been helpful in increasing the coverage of refunds that we do automatically. So like back at, not just automatically, but with the risk engine in general, back when we started, it was only about 60% of refunds that were assessed by the risk engine. So basically, like, with different rules that can calculate if it's a good idea to give it or not. Now it's, by the end of the year, probably going to be 100%. So every refund that we do is going to go through this backend. And it's been used to block about 60,000 refunds and grants. It's helped grant, like, I think more than 1.2 million. The first iteration that we did was only for missing items or mistaken items. So like, yeah, you have one, like the fries, they are missing. And but we have since then expanded it to now undelivered orders, bad quality, and orders that are late. So basically, to summarize, we wanted to make the system easier for normal customers, block abusers, and reduce cost. It was quite difficult because, yeah, we identifying abusive customers in general is difficult. Then we created, this risk score with an unsupervised anomaly detection model. And so far it's been fairly successful, even though it still has our little problems that we're working on. And yeah, thank you very much.